All right. Thank you guys for your patience. Appreciate it. I don't expect to have so much delay for our next sessions. I will remember my charger. So we're taking basic model building here over the next 4 weeks, not 8 weeks like I originally said in the Slack message. Initially 8 classes, 4 weeks. So this will be kind of a scope and overview of machine learning, and we'll touch a little bit on deep learning. We don't have enough time to really dive into all of the mathematical rigor and underpinnings, but I'm going to try to give you guys a little bit of an intuition for at least 2 algorithms. And the first one will be gradient descent, and then the second one will be decision trees. And I think with that foundational knowledge, you can use that to lean into a lot of other algorithms, and you can really start to begin to explore and understand the space using that. So my goal is going to be to set you up with all of the tools, kind of nomenclature, everything you need to sort of just explore the space and continue learning on your own outside of this class. I'll get to the syllabus here in a moment. I'm jumping ahead. First of all, my name is Emily Kinney. I work as the director for advanced analytics for an insurance company that's based out of Portland, Oregon. So I actually work remotely. I've been there for about 2.5 years. And we have a team that specializes in building AI products such as chatbots using ChatGPT, AI assistants, both internally and externally. And then we also have kind of a data science function. So your traditional machine learning, predicting the disability duration that somebody is going to be out for so that we can help them recover sooner and get back to work sooner. And I've been in data science for, trying to do math in my head real quick, maybe about 8 years. So 2 years here. Prior to this, I worked for Mutual of Omaha, so I worked there for 7 years. Worked in data science over there doing exactly the same thing that I kind of do for my current company today. My academic background is in bioinformatics. I studied that at UNO, so it's really an interdisciplinary field that uses machine learning, a lot of the techniques we're going to be using today, but the data set is instead DNA. So one common application was, COVID happened. That was a big deal, and it was a new novel virus, and so we had to sequence that DNA. So that's bioinformatics. That's kind of the discipline that came from. So yeah, that's maybe a little bit about me. I have a little son. He's 1 year old. So that takes up pretty much the rest of my time outside of work and this stuff. It would be great if we did some introductions. Maybe we'll just go around the room here, and then we'll switch to our virtual participants as well. If you guys could introduce yourself, maybe say what your background is and what you're interested in getting out of this class.
Okay. I'm Missy Manchester. I am a data engineer in Bellevue Public Schools. I've been in data engineering for probably 7, 8 years now. And we heard about this as part of a grant through the state and thought it would be super interesting. We are trying to build some models to look at grad rates. So take all the data about a student over their lifespan and see what's the probability that we will graduate that student. And then if they're not on track to graduate, then we can implement some sort of help for them before they just don't graduate.
That's interesting. Excuse me if I take notes.
Yeah.
So I am Anna.
Just your background, whatever you're interested in, and what you hope to get out of this class.
My background is mostly in nonprofit doing taxes for free for individuals that are low to moderate income. But I do want to switch into like data analytics. Find it very interesting. And so I hope to eventually, by the end of this class, transition into a career into data analytics. That's my goal this year.
So my name is Brenda Aguero Carranza, and I'm also not in the data science field yet. I work with individuals with disabilities, primarily 14 and 21 ages. So I work with high school students up to transition or young adult programs. I've applied some of the data just to provide insight about my team. But I'm hoping that I could transition from where I'm at to something different.
All right, I'm gonna try to turn up my volume here. If we could hear from you guys on the phone, I'm just gonna go in order of the way that people appear on my screen. So Matt, if you could introduce yourself.
Yeah, my name is Matt Goffey. I'm based out of Denver, Colorado. My background right now is I have a degree in business intelligence analytics, and I currently do analytics support for a software company. What I'm hoping to get out of this class is just to learn some new skills, refresh on some stuff I learned in school, and just to essentially learn some new stuff and hopefully apply it into my career later down the road.
Good to meet you, Matt. All right, Ted.
Hi, everyone. Ted Ottenheimer here. I know a couple of individuals on the phone or on this group, so great to be back this year. Background is doing data analysis from healthcare and, going through how nurses utilize and leverage our tools and technology or how they don't use it. So one of the things that I've really found is that there is life outside of Excel, and it's an easier way to do it. So I'm interested in learning all of these fun things. And of course, I've done the data viz and some other things with this, but truly looking forward to this.
Great. Glad to have you. And James.
Hi, I'm James, located out of Houston, Texas. I got my degree in IT, did some basic IT work out of undergrad, and now I work with Ted at the same company, but I'm the implementation side of it. Looking forward to this class to really learn about machine learning. I've never done anything with machine learning before, so that's it for me.
Wonderful. You guys will be excited. Thank you all, by the way. It's great to see that everybody has a really diverse background. I'm hoping to be able to pull all this together. Our goal for this course, by the way, is we're going to build a model every single day. So even by the end of today, we're going to have a model built. You'll see that maybe that definition isn't as strong for today as it will be at the end of the course here. So I apologize as I try to do unnatural mouse movements here. Okay, so our agenda for today, we did our introduction. I'm going to jump into the class syllabus and probably run through that pretty fast. And then we might just skip the break so we can jump into setup and getting started. I think it's really important that we all just kind of maybe walk through that together and work out any issues that may arise. And then we're going to be in a good spot for the rest of the classes to work through some stuff. And then if we have time in that third hour, we're going to focus on, we'll take a little 10-minute break. And then the third hour, we will focus on Python basics review. You guys are probably already familiar. I know a lot of you have Python background or have already gone through the Python class, but I think it helps to refresh our mind and reorient back on some basic concepts. And I'll have some resources for you guys for that. The structure that we have in this third part is the structure we're going to follow for the rest of the classes. At least that's my plan. We're going to do about 30 to 40 minutes of lecture, and then we'll do a breakout activity. So we'll have a hands-on exercise. We're actually going to work together through that and try to apply those concepts. And then we'll have a little break, and then we'll move into the next topic. So we're going to flow through that. Perfect timing, Nate.
Yes.
We got a little delayed, but we're getting back on track here.
You're fine. I'm gonna steal 30 minutes and put you really off track.
Here's the camera if you want to talk to our online friends.
What's up, yo?
Hey, Nate. How are you?
Good. Welcome back, everybody. It has been a long time coming. So thanks, everybody, for coming. We are, just like Sesame Street, we are brought to you by the letter N. So the state of Nebraska enlightened me with a giant sum of money. And that dollars are specifically designed for workforce development. And we are very lucky to have all of this paid for by that, which means that you guys and your organizations get free training for not only data science or not only machine learning, but if you guys want to come back around and take data engineering, we'll probably have an AI cert, so like a large language model cert this fall. Likely a cyber cert. We'll ferret one of those out, and a Python programming cert. All of that stuff is available to you guys to learn. My goal is to make you as good as tech as I can, and so we're really excited about that. There are two caveats. One is I have to write a really nice report at the end of each year, and I need to track things like zip code, gender, BIPOC, low socioeconomic, things like your dollars before you became a data scientist and your dollars after you became a data scientist. Of course, the state would like to know, we gave you X amount of dollars. Did you create X amount of tax revenue? For those that are out of state, that's okay, because this still helps you. And I only got to be 70%. The grant's only going to be 70% of people in state, so we're good. But yeah, I wanted to tell you how exciting this was and why, and how we got greenlit. So really excited about that. Logistically, just like always, we're recording this. It is for you guys. It is on YouTube behind a password so that you can get to it, but it's not exposed to the world. But we want you guys to have access to these videos so that if you ever, 6 months from now need to remember how to do an outer join in SQL, well, you still have access to that. Remember, there's some new people on here, not just the same crew from BI. And so we wanted to welcome Matt and Missy.
Yep.
Yes. Okay. Matt and Missy, these are your new friends. Everybody, this is Matt and Missy. They're your peers. Also wanted to introduce you to Emily. I know you already said hello, but she's just the best, and consider her a mentor moving forward. She runs a whole data science team, y'all. That's how good she is. So she's awesome. I couldn't have found a better person to teach you. And I have more amazing teachers in the pipeline for mathematics and cloud. So really excited for you guys to learn from us. And then if you decide to come back and take a data engineering course, or if you decide to come back and take a programming course, of course, everybody that, and this was, I was just down at the BI class who are just starting their journey. And it is always interesting to watch people and said, listen, the person that teaches you at every single one of these classes does this from 8 to 5. This is their full-time job. This is what they do. And then they show up at class and they're like, hey, listen, today I was doing this. And it's that level of knowledge that I'm so excited for you guys to get. Logistics for everybody in the room. Did you go over this?
No.
Okay.
Logistics.
Restrooms around the corner, right? If there is a fire or some sort of thing you need to evacuate, you guys came up those stairs, go back up those stairs. That door's locked from the outside, but not from the inside. Go outside. If there is a tornado, probably not going to happen in February, but as this thing goes into March and April, it is Nebraska. Keep going down. There's a set of stairs that goes down into the basement where there's a parking garage. Please do not go outside. Okay. Snacks, drinks, 6 to 9. Parking, we already covered parking.
Yeah.
I don't know. I think it's it. You guys have my number. My cell phone number is on every email. You're free to call me at any point. I'm so excited for this to be going again, for you guys to be learning again, and the community desperately needs you. So learn all up. Oh, that was what I was going to do. The grant also covers internships. So if you guys are interested in, well, you're not, but if you're interested in being in an internship, we pay 25. A lot of times the companies will juice that for 90 days. There is a job fair coming for those who are looking. I will help you polish your resume and your LinkedIn. You're probably beyond that, but I will help you with that. I will help you with job interview questions if you so desire. My job is to get you hired because this money says that I have to. So yes, I want to as well, but I have somebody grading me on it, so now I really have to. But I am so excited and just wanted to say hi to you guys again. It has been way too long since we all saw each other and met each other, and it's so nice to meet the new faces. I get this way about this stuff all the time, so I'm a nerd. Let me know how I can help. Back to your regularly scheduled broadcast.
Thank you, Nate.
Good? All right. Call me if you need anything, guys.
All right. We're going to continue on here. Okay. Let's dive into the syllabus so that we can start working through that. And I may sit at the chair.
Did you go live?
Yes. Yes.
Okay.
Went live.
Good job. Charlie didn't.
I almost forgot.
You were better than Charlie.
Almost
Charlie
forgot.
He was 5 minutes in. He's like, oh, crap. Good job.
All right. Let's. I think it's great, guys. Let's see if I can get this done. Okay, I'm gonna move over here, so apologize if you guys won't see me. I'll try to move back and forth, but I can't make my mouse movement go inverted. So our course description here. Zoom in because we can read that. And I will share this in the Slack channel. I'll probably use most of the Slack channels for communication. I think that typically works really well. And if you guys have any questions, just as we work through the field, through the course, please ask those. Try to ask them in the Slack channel if you're comfortable, just so other students can see that as well, and we're kind of getting that exposure for everybody. But I talked about this course description here, how we're going to work through the field of machine learning. We're going to focus on concepts, nomenclature, resources, and methodology. And I'll leave it to you guys to kind of put all those pieces together and figure out how that fits into various problems. So we're going to focus on a really foundational knowledge that's going to enable self-teaching. That's my focus here. We'll start with a refresher on Python, and then we'll move to linear and logistic regression. And through those algorithms, specific homework assignment we'll have is to implement gradient descent. And I'll set up the framework so it's not from scratch. But that's one algorithm that's very, very relevant in the field of machine learning and in the field of kind of data science in general. If you think about neural networks, this is the algorithm that drives neural networks. It's gradient descent. So you'll see this come up over and over again. It's a really good algorithm to understand the underpinnings, and it's kind of natural the way that it's implemented. So it's a good place to start. And then before we move forward into more types of models, classification, and trees, we're going to take a moment, pause, and talk about modeling methodology. How do we make sure that we're not data snooping? How do we have best practices for modeling so that when we're building a model, it's representative of the real world and we're not lying to ourselves about how well it's doing? So we're going to pause and do that, and then we're going to move on to trees and ensembles. And I have all this in the schedule down below. So with all this in mind, if there's time, we'll talk on models in production, what that looks like. And then along the way, we'll do weekly coding assignments, and final exam is a strong word, but just a concept check at the end of the course. And just to show how it applies to real world applications. This is just, really it's for me to make sure that the way that I'm teaching this is settling in with you guys well. So it's kind of a sanity check for me. And then open-ended final project is a strong word. I'm not going to have you guys do like a presentation or a paper or anything. We just don't have time for that. But just a little friendly competition in who can train the most competitive model on a data set. This is what we're going to work together. So we're going to build the pieces to get there in a very short period of time. And then we'll see who tunes the best performance for a simple model application. Okay, so I'm assuming, here are the things that I'm making assumptions on, and if this is not correct, please let me know. I'm happy to provide support or resources. I'm assuming a basic knowledge of Python. And I'm assuming that you have either a data analytics background or business analytics. You're familiar with like kind of the foundations of statistics. So we're not going to go over like histograms, box plots, all that type of stuff. I'm going to, these are the prerequisites. By the end of this course, I hope that you guys will be able to demonstrate familiarity with concepts, understand and apply them to machine learning problems. You're proficient with the key Python packages that are relevant in the field today, and you can direct your own learning into these emerging technology and tools because it changes every day. Okay, there's no textbook. I'm not going to have you guys read anything. Again, we just so much to cover. We don't have time. However, I have a couple of, I love books. I'm a big book person, so I have a couple of books, and I'm going to stand up and show these guys as well. So the first book I would recommend is An Introduction to Statistical Learning. This is available online. It's free PDF. This one's in R, but they actually recently just came out, released a new version that has Python exercises. I haven't looked at it, but this is a very, very well-known book in the field. And this is the, I would say, the introduction version. There's a more sophisticated version that goes into the mathematical underpinnings that's also very good. It's a little dense. That one's called The Elements of Statistical Learning. That one's not free. It's a little pricey. But this one, free online, Introduction to Statistical Learning. It has exercises and everything. I would highly recommend. So I use this as kind of the guide for the course. I think for this first week, and I really do, I've read this book substantially. You can see my highlighting. So let's see there. So for this first course, or this first week, I think if you're going to read this book, I would recommend starting on chapter 2 on what is statistical learning. My book might be a little different in the updated book. On my book, it's page 15, but it talks about what is F, meaning what is a function? What is this that we're trying to predict? When we're trying to say we're trying to predict something, what does that even mean? And what is y hat and all this terminology? So I would recommend kind of that what is statistical learning section from that. Okay, enough about that book. The next book, if you are kind of new to Python or just kind of getting into Python, again, these are all books that I've read. You can see all highlighted. Think Python. I think this is a really, really good resource for just very approachable, really friendly way of wording. You can find most of the stuff on the internet, but sometimes it's kind of hard and you have to dig. This is just like a good reference for how to program in Python. As we work through this class, you're going to have a couple of assignments. I'll get to that. I just realized I haven't got to that part yet. A couple of assignments. You're going to have 3 assignments and then 1 model submission at the end, and then the exam. It's a strong word. But the assignments and the model training is really to your benefit, so you can add this to your own.
Look what I found.
We got another friend. That's great. Welcome. Please sit.
Thank you, Brenda, for finding our wayward soul.
Sit anywhere you'd like.
See where you want.
Yeah, sorry, I've kind of taken like 3 chairs in here, but I'm a bit expansive. Apologize.
Was in the wrong class.
Well, welcome. By the way, what's your name?
Charity.
Well, I'm glad that we got you instead.
I was with Charlie.
Stole you from Charlie.
They're probably like, where did she go?
Welcome, Charity. And tell us about your background and maybe what you hope. We already all did introductions, so sorry to put you on the spot here. But your background and maybe what you hope to get out of this class.
What class is this?
That's a good question. Maybe I'll give you a minute to get settled. This is Introduction to Machine Learning or Basics of Model Building. I think we've termed it in a couple different ways. We'll come back. Okay, so there's a site, GitHub. You guys may be familiar with it already. If you don't have an account, I would highly recommend. It's free. Recommend creating an account. All it is it's a place to store your code, and it does a lot of cool stuff. Versioning. We won't get into that, but basically, I'm going to drop links probably from my repository. It's a little disorganized, so apologize. For you guys to have your assignments and things to work on, but it's a great place to store your work. So as you are going into interviews, as you're trying to build that resume, I just put my GitHub link right on my resume, and then they can go to my projects, or if there's specific projects you want to call out. Resumes are very digital in today's world. You just can link straight to them. So I would recommend as you do your assignments, just put those on your GitHub repository. They can be great demonstrations of your work. Anyways, if you're curious about how Git works, because it can be a bit confusing, especially kind of the first times getting familiar with it, Pro Git. This is a great book. It's also free online, so there's a web version. You don't even have to buy it. But it really describes what Git is, what version control is, why it's powerful, and how to use all the cool, complex functions about it. I think on this I have a typo. Yeah, I put the Python for Data Science Handbook. I'll fix that. I actually prefer this book over that one. This is Python for Data Analysis. I think if you're looking for a book about how to approach exploring data, I think this one's actually a little bit better. I think the Data Science Handbook's a little dense and actually kind of difficult to navigate, but this one seems a little better structured in terms of organization. So as we dive into pandas and NumPy and all the really common packages, I'm probably going to reference this book as a resource for that. Also, you can just find all this stuff online. And again, I'll point you to reputable resources, but you guys can also borrow these whenever you want. I don't typically reread them. Happy to loan those out. Okay. Let's keep going through this syllabus. Class schedule and grading. Okay, so the topics for this course, we're going to start with, today we're going through introduction and getting started. By the end of the week, we're going to dive into like a Python review, and we're going to start to understand what is this pandas thing that everybody talks about. You'll hear that a lot in the field of data science and machine learning. You guys might already be familiar with it. I'm not sure. Maybe I should take a survey, but we'll talk about the data structures in there. So what is a data frame? What is a series? What's the difference between those? How do you use those? And then starting the second week, we're going to get into data wrangling and visualizations. And finally, we need all of that background in order to start working with linear regression, logistic regression, gradient descent. Like I said, we're going to take a pause, talk about modeling methodology before we continue on. And then we're going to get into the other type of models, which are classification models. In machine learning, there's two domains. There's a lot of domains, but I'm going to oversimplify here. There is classification models and regression models. So regression models are, you're trying to predict a number, maybe the price of a house. And classification models are, you're trying to predict a label on something. Are they apples or bananas? We're going to briefly touch on unsupervised learning and deep learning in week 7. And then we're going to get to the end of the exam, or end of the course, with model challenge and a course exam. And then if time, during that 8 session, I'll talk about serving models to production. Okay, grading. This is pass-fail, so really you don't have to get so detailed on the exact percentages here, but this just helps me organize how things are going to be attributed. So 3 homework assignments at 15% each, an exam at 20%, final model at 30%, participation at 5%. So if you show up to everything and you build a final model that's reasonable and you did all your homework assignments, don't even need the exam, so don't worry too much about that. Again, it's just a test of concepts. So this is, again, just pass-fail, 70 above, 69 below. And then just talks about the schedule, weeks 1 through 3. We'll solidify concepts, weeks 4. We'll do that final exam. Okay, this just says that we're going to do this live session and breakout activities, etc. Okay, I will send this to you guys. Time check. We are at about 7 o'clock. Okay, we made it. We fit all that in. Good. Now we're up to, yeah, I should pause here. Any questions? All right. Any questions from our online presence?
No, sounds all very good and clear. Thanks.
Great. All right. Please let me know if I go too fast or talk too much. I have both of those problems. All right, let us dive into the second part here. We're just going to go ahead and start getting set up. So we're going to do, again, I would recommend GitHub and Git if you guys don't already have that. I'm trying to pull stuff up on my computer here. Okay. This is I hope I updated this. Okay, so if you guys could, I apologize as I switch back and forth here. I'm going to drop this in the Slack channel. If you could go to this section, and then I'll drop the exact link, and then follow along with me. So this is a GitHub repository, which just means it's a bunch of folders that have things in it. And we're going to go to let's go to a different branch. So up here, there's different branches. If you click on Python for DS, that's one, and then click on Learning Paths, and then click on 0, Python for DS. We're going to go into this Introduction to Python. So you can just follow along on here if you'd like. I'm going to open it in Jupyter Notebooks. I promise I'll get into what Jupyter Notebooks are and such things. But if you ever want to, if you have a Mac, you can do this on PC as well. You just would use a different interface. You just type in Jupyter Notebook, and it will open up a notebook of whatever directory you are in. For me, that is actually not the directory that I wanted to be in. Change it.
Volunteer through me. I know, it's like, wait, this
Oh.
isn't right.
Yeah, sorry about that. I'm gonna have to move this. Next time I will fix this so I'm not going back and forth here. Okay. Okay, there we are. Oh, if you want to open this in that's a great question. If you want to open this in a Jupyter notebook, okay, so if you want to open this in a Jupyter notebook, you just put JUPYTER space notebook and you hit enter, but it's going to open that wherever you are located. So if we do PWD or project working directory, it'll show you where you're at. So I'm in users, Emily Kenny, repositories, ML teaching material. I would recommend that you make, if you're going to make repositories, that you create a repositories or my code or something file folder. And these are all just, this is exactly what these are. So let me just maybe pull up a more familiar user interface here for you guys. Okay. So if you go into repositories, you can see all of these repositories. So I just created a folder under kind of my main directory area called repositories. And then this is where I store all of my code. I'll come back to this. For now, if you guys want, you can just open it in this Git link. You just have it open on there.
How do you download it from Git?
That's a good question. So if we go to this Git link, there's going to be a download button right here. You click download. It'll drop it up here.
Let me see it down.
We'll have one of these here.
Okay. So we have to go into it.
Yes.
Okay, thank you.
You're welcome. So that's one way you can do it. You can also do trying to think of how I should organize this for you guys. Let's just get into the Git stuff right now. All right. I feel like I'm holding off for no reason.
I don't see learning paths. I see ML teaching material.
Oh, so under this, try to change this to Python for DS.
Thank you.
Yeah, so in Git, you can do different features. So you can have, some of your code can look different from other sections of your code. I should have put this all on main, but I have not. And then click into 0, Python for DS. There's a bunch of stuff we won't go through in here, but we will be starting with the intro to Python. So then if you just click this, intro to Python, this should pop up.
Okay, perfect.
And then for now, I'm just going to say, click the download button. And then in your own instance of, there we go. In your own instance of Jupyter. So now go back to your, either your terminal or the Mac equivalent of that, or the PC equivalent is PowerShell, I think, right? And then create a folder, and then you can just drop the notebook in there.
Okay.
Yeah. I'll just do it now. Hold on. This is probably too hard. Sorry. Let me see if I can turn this. I'm going to change this computer view so I don't step back and forth. Okay. Here's what we're going to do. All right. So I am in my main, wherever you want to start at. And I'm going to make a new folder. So we're just going to file new folder. I'm going to call it repositories 2. And then let's click into here. Okay, there is nothing in here in my kind of navigation terminal, by the way. If I go CD tilde will take you home. And I can see that I am in Emily Kenny, and I can CD into repositories 2. CD means change directory. Yeah, you got it. Okay. And we can see that there's nothing in here. So we're just going to download this file. Click the download button here. There are a million ways we could do that. We're just going to do it this way for now. And move these around so that I can actually drag and drop that onto here. Oh, got lots of downloads here. Then we're going to move that over. And now that we have that moved over and we're in the right repository, we're going to do Jupyter Notebook. The Jupyter Notebook will only work if you have Jupyter Notebook installed. And then you can see this is the notebook, and you click on it, and now it is open and you can run it. Jupyter Notebook automatically comes with the Anaconda distribution. So if you install Anaconda, it's going to make your life a little easier. And it will do some, like, you can do Conda install. It'll do some package management for you. Again, this is recorded, so you might have to wade through some of my ramblings, but this will all be back for you guys. All right, so we're going to walk through the Python introduction. All right. Python's a pretty cool programming language. It's really popular because it's powerful in its readability. So if you work through Python as we go through some of this, you'll see that it's almost like you're reading human language, and you don't have so much like pomp and circumstance that some of the other languages have. So Java, you public static void main. What does that even mean, and why do we have to do that? So it's a little more friendly in its approach, and it's super readable. It's open source, so it's fairly well developed. It's very thoughtful, I've found, in some of its approaches. And what's really powerful about it is you can do either object-oriented or script programming. So in this class, we're not doing any I'm not teaching object-oriented programming. I'm going to try to keep it mostly script-focused, but you'll see the object-oriented sneaking its way in because it is so instrumental and powerful. So we will get to that. That covers actually a lot of the pros of that. It's very portable, and sklearn's a very substantiated, well-substantiated machine learning package that we will use. All of that is Python-based. And so it has a lot of support for the language in the field of machine learning. The downside that you'll see as you move towards like production companies, if you think about really big enterprise companies that are deploying things, Netflix and the Amazons of the world, it's too slow. The language is too slow. And that's because it's way up here. It's a really high level language. And so you'll see them working in C and some other languages in PySpark to optimize that and make it faster. So these are some cool applications of it. What's really neat about Python is not just data scientists use this language. If you contrast it with R, which is another common language for the field, that's mainly just statistics. But Python is used also in application development, in web development. It has a variety of applications, so that makes it very well supported. And it's one of these higher level programming languages. So as we get really close to the machine, we have these low level, binary zeros and ones, and it's not human readable, but it's really fast, and it communicates really well with the computer. And as we move higher and higher up this pyramid, we get to the ones that are closer to our language, easier for us to understand, but it actually takes quite a bit of like compilation and interpretation for that to get back down to the machine. code. So that's the trade-off there. I'm not going to go into that. You may notice one thing I probably should know. It's not so relevant anymore. It used to be, but there's Python 2x and Python 3x, and they're not compatible. I think everybody's on 3x now, so it's not such an issue. You don't have to worry about compiling with Python. That gets abstracted, so we're going to move on. There are different types of data in Python. So everything is an object in Python. The concept of objects is really important. Again, I won't dive into it, but we have numeric things like integers, 1, 2, 3, 4, 5, floats, 1.0, 1.7, 3.794. We have dictionaries, which are key value lookups. We have Booleans, true, false. Maybe this is all coming back to you guys. We have sequence types. We have strings, tuples, lists. Okay, so we're gonna fly through this. And again, this is available for you. So you can run type on anything, and it'll tell you what type it is. So we have this type on 1, 2, 3, 4. And in Python, unlike other languages, we don't have to say 1, 2, 3, 4 is an int. It infers that 1, 2, 3, 4 is an int. So it has kind of this intelligent sensing in the language of being able to understand what that type is. It's super nice. So you don't have to, it can cause some problems at times. It makes testing and debugging just a little bit harder, but it is so much faster in terms of getting set up and writing the code. So here's just some different types that this can be. I don't remember what I was trying to say here with strings. So what's really another cool thing about Python that isn't always the same with other languages is you can have multiple types of objects in a list. So a list does not have to be of all one type. You can see that this is actually a list of lists. So on the outer side here, we have the full list. And then on the inside here, we have another list inside that list. But there's also an integer and a float in here. And then inside this list, we actually have a string value, and then we have a integer as well, and that all works. We're not getting absurd errors out of that, which is seems small, but is a big deal in other languages. Again, there's functions you can use. So range will create you a range of numbers. I didn't even show what this looks like. We'll create a range of numbers from 0 and 10. It's actually a generator, so that's why that is not printing. So I need to create a list with this. There we go. So this is a cast. This will cast anything into a list, and it takes in this generator of range, and that's too much detail. You don't need all that. Okay, so then we have dictionaries. This is a key value lookup. So you can give it the key of food, and it'll look up spam. You can give it the key of taste, and it'll look up yum. You can do it the other way as well. Tuples, this is a tuple representation. The difference between a tuple and a list is when you create a tuple, we use these round brackets instead of the square brackets. So the list you will see will be square brackets, and the tuple will be round brackets. Tuples are immutable. Lists are mutable. So lists, you can change values within there. You cannot change tuples. So there's different situations when you might want to use a tuple versus a list. Let me see, what else?
I'm sorry, tuples are mutable or immutable?
I hope I'm saying that correctly. Strings and tuples are immutable. Okay. I had to do a sanity check there. Yes. So if we create a tuple here named tuple, I can't, we can just try it out. Here we go. Let's try to change name tuple at 1, which is the word spam. Python 0 indexed. Remember, so it's going name tuple at 0 is actually the 1, at 2 is spam. We're going to try to change that value to eggs. but it won't let me. Oh, wait. Name tuple isn't fine. There we go. Tuple doesn't support item assignments. When I say a tuple is immutable, that's what I mean. We can, of course, overwrite the tuple. So we can say name tuple equals eggs, and now it's a totally different, now it's just the string eggs instead of, that doesn't make any sense, but you get what I'm saying here. There are actually functions associated with tuples, though, that will allow you to manipulate them. So you can do name tuple dot. Let's look it up. Python tuple functions. Here we go. This website sometimes has some decent things. So this will go through this and say, let's see if we can find them. Okay, that's the constructor. I don't see any. Anyways, I promise there are functions. I won't spend more than 5 minutes looking for that. So there's different things you can do with tuples and lists. Let's see, sets. This is a set constructor. It's going to break this down into ABC set. I think we'll need a lot of this. Booleans are true, false values. And so sometimes we use this a lot if we're trying to assess. If you assess is 5 equal to 6, you have to use, instead of the, there's two operators, there's something called the assignment operator, and then there's equality operators. So don't get those confused. This would assign, well, it wouldn't let you assign the value of 6 to 5, but if we had that as a string, it would do an assignment to that. This is equality. If you assess, is this that, or is this this? So those are that. None is another important, this is its own type of object, and you might have heard in other languages null. In Python, it's called none. So this is our nothing exists in that value. You can kind of think of it as like an empty space, but instead of checking each field for an empty space, or what if they're integers, then how do you represent an empty space? They do this with the none object. So there's a lot of functions that use none that just says dot is NA. So when you're doing Python kind of analysis or EDA or modeling, you're going to want to convert any of your representations for missing data to this none type, because your machine learning models will use that. It assumes that if something is none, that it's actually represented as none. So if you have somebody answering a survey, for example, and they say decline to answer, maybe you want to actually represent that as none in your case. We'll get into that. There's many things confusing about Python. One thing that is confusing is the way of printing. There's about 15 different ways that you can print stuff. So just the basic one is, the standard programming hello world. You can all do print hello world, and it'll print this to your command here. You can also do printf. This is my personal favorite. Whenever I'm printing, I use this because I can pass variables to it without having to do a lot of other extraneous stuff. So I can say this is my first variable, and those are all strings. But then the moment that you put two curly braces together in here, and I want to pass a string, which is this variable here, which I have to run this cell where that won't be available. Then we run print, and it says, this is my first variable, So I like the printf, or sometimes they call this format print. It's a really friendly way to interact with that printing function. Again, there's other ways you might see on the internet, print dot format. That's kind of an older way of doing it before this one came out. So there's a bunch of different ways you can print. When making comments, you'll see that if you make a hashtag, anything followed by that will not run. It's ignored by the underlying Python interpreter, which the interpreter is the actual engine that runs and executes your code. So it'll ignore anything after the hashtag. If you want to do like a bunch of lines of comments and you get tired of hitting the hashtag or pound sign every time. You can do three quotes, and then it'll make a multi-line comment. So you can type everything you want, and then at the ending of those 3 quotes, you close it, and then that's done. So I'll show you one other trick when I'm debugging. If I have like variable X and I want to, I don't know, I'm just going to put a bunch of stuff here. If I have a bunch of lines of code and I'm trying to debug and I want to comment out some of them, you can highlight all of them, hit Command, and then your /. It will actually comment all those for you. And then you found your bug, you're done. Command / again, it will uncomment all of those.
You said /.
Command / on might be a little different on a PC than a Mac. Might be the Windows button probably. When I'm just going to follow my train of thought here. I'm going to jump to say something about Jupyter here, so I apologize for the disorganization. When working in Jupyter, you can use your arrow keys to go up and down within a cell. But if you hit the escape button, do you see how that turned from green to blue? I'll do it one more time here. It's green. If you hit the escape button, it'll turn blue. And then you can actually navigate up and down through the cells with your keys. So that's a little easier. And then if you want to get into a cell without actually touching your mouse, the ultimate goal for like any programmer is to never actually have to touch their mouse. You can hit the enter button and that'll take you into the cell and then you can navigate within there. So I'll come back to more about Jupyter here after we fly through this, this stuff. So variable assignment, we already talked a little bit about this. Like I said, this is called the assignment operator, 1 = sign. There's certain things that are illegal or reserved in Python. A couple of them are like keywords. I'm trying to think of one right now. Int is a keyword because it is a variable, because it's an object that you can use that has functions that you can cast. So you can't call your name an int. I can't do that, for example. You also can't end with a $. You can't have a star in the middle. So there's a couple things that you may notice that you can't name certain variables. Python will probably tell you if you try to do that. I mean, I can try to run this and it says, there we go, invalid syntax. So you can paste that into Google. It'll probably tell you why that's invalid. Let's see. You can't change the value of 3. We talked about that. You can't, inherit numbers. That would be really confusing. Probably good. It's keeping us from ourselves a little bit, which is nice. Okay, let's see. Numeric operations. Okay, there are a couple things to note here. I don't think we're going to particularly use any of them, but there is an operator. So you have your basic operators. In Python, they're really standard, which is nice. Your plus sign's a plus, your slash sign's a divide. They work exactly as you would expect. If you haven't taken a programming class before, you may not be familiar with the remainder operator, but it's pretty cool. So if we do 100 divided by 2, what is the remainder left over from that operation? Or if we do 3 divided by 2, that would be 1 would be left over. 2 only goes in 3 one time, etc. So there's a remainder operator. I don't think we'll need that, but it's kind of neat. Incrementing is another thing that's a little different. So if you're going through a loop and you're saying for everything that exists in this list, do something, you might want to add 1. You can do count plus 1. That's a little verbose. So you can actually do plus = 1, and it'll just add 1 or add whatever to this object that you're working with. You can actually do that with a decrement too. So you can do minus = 3. You can do divide equals, and then 2 stars is the power operator in Python. Sometimes this is maybe more relevant for the work that we're going to do. Your data type's not going to be in the right format. So you're going to be reading in an Excel sheet, and it's going to read in all your integers as a float. And then you're going to go try to calculate the average of that. And it's going to say, well, I don't know what the average is of a bunch of strings. That doesn't make sense. And so you're going to have to cast. So casting is anytime you change one data type to another data type. So I have my float here, and then I'm going to wrap it in this operator. So I'm going to call int, and then I'm going to open a parentheses and then pass my value to it, and then I'm going to close the parentheses, and that will make that value of the other type. It'll make it of type int, if it can. If it can cast it to an int, it will. This random function is really useful. We'll use this a lot. It does a lot of different things. It can make a random number for you. It can make a series of random numbers. There are a lot of different functions that go with this. And we will talk more about functions next time, by the way. It's a little hard in this course because you, like, where to start with it and just have enough knowledge to navigate. So I apologize if I use some words that we haven't gotten to yet. I promise we'll get there. So string operations, you can do operations on strings. So this word spam is actually stored as an S, then a P, then an A, then an M. So if you do S at 0, it actually returns it, or I'm saying S is my variable name here, actually returns a S. If you do it at -1, so unique thing about Python, that some other languages don't have, you can go backwards in the list. So you can do -1, -2, -3. So if we did -3, it would actually return a P. So it would start at the end, -1, -2, -3, which is cool. So it's kind of neat. Sometimes it's useful. Concatenation, so we can add things together. This one I actually do use quite a bit, and I think I even have this for our exercise today. Anytime you can take a string or a number times a number or a list times a number, and it'll give you that many of that item. So it's kind of a really easy way. If you're like, I need a list of 10 ones in a string, you just list 1 times 10, there you go. Strings are immutable. List operations. Okay, we're going to skip these. Conditional statements. So one thing in programming language is like conditional flow, like where in the program is your code as you're moving through like while loops, if statements. And again, Python, super readable. So we have B at 200, A at 33. If B is greater than A, then print this. So it'll print that. We can swap this around and you can see what this logic does. If we make it less than, it doesn't print it. So this code that is indented inside of this if statement only runs if this condition evaluates to be true. So in Python, we'll have, you can see this is a keyword. We'll have if and then some type of condition. And it can be really complex. You can have a bunch of ands and ors. If B is greater than A and A is less than C, or this happens. So you'll have a logical condition here. And at the end of this whole logical condition, no matter how long it is, it either evaluates to a Boolean. It's either true or it's false at the end of that. And then if it's true, do logic that exists inside of this indented scheme here. And if it's false, don't do this logic. In Python, we rely almost to a fault on tabbing indentation. So anything outside of this, print, I'm not in. This is not in the loop. So even if this evaluates to false, which we talked about how if it's less, this still prints because this indentation is aligned at the start of this, where the rest of this code is. So indentation is really important in Python. It equates 4 spaces to 1 indent, depending on your interpreter. That's kind of the default. So if you pick up somebody else's code and there's some like issues with indentation or the code's throwing errors and you don't know why, you might want to check the indents or the spaces. Okay, so again, you can check these out. They're just different ways of doing conditional statements. We have or, and interesting is not. So if this is not true, so if this evaluates to true, it automatically flips that to a false. If this evaluates to false, it automatically flips that to a true. While loops can be dangerous because they can run forever if this condition is never met. So sometimes we try to shy away from them. Functions, we'll talk about more tomorrow. Okay, where are we at? 7:30, we're doing good. That was a lot. I apologize. This is meant to be just more a resource for you guys. I think you guys have some background in Python. Correct me if I'm wrong. But now we can dive into our exercise here. So let's do, I'm going to drop this link in the chat. Let's do, oh, that's, all right, that's assignment 1. Trying to remember where I put it. I apologize. It's Python Basics. There it is. Okay, if you guys could download this, try to open it in Jupyter, and then just let me know what issues you have opening this. We'll take a break, let you guys read through this. There's a lot of parts. I don't think we'll get through all of them. This first part is just working with text. So in Python, sometimes there's something called like an escape character when you're trying to print, and it is the /. So I'll just, I'll let you guys kind of work through this, and then I'll show the answers to that. Then we have flow control. So this one has an error in it. You need to figure out how to get this to run kind of logically. This one, if we have time, is just messing with operation functions and getting that to output in the way it says for sample output. And then, again, there's a lot here. We'll just start with those first couple. Yes, of course. I'm gonna walk this way so I don't trip on my cord. Oh, perfect. You should be able to go into, oh yeah, and see the thing. I think where it starts right here. Let's open up your terminal. So if you hit Command Spacebar, I'm glad you have a Mac set up, and then type in terminal. I truly haven't used a Windows in 7 years. I would do lots. And then hit enter. So this thing's great. This is all terminal commands. I'll send a Git cheat sheet in the terminal cheat sheet, but let's go. Let's do mkdir. So dir. That would be very good. It stands for log directory, dir. And then hit space. And then put repositories, repos or something. That's fine. Perfect. So now do ls space -l. Show you where this is, -l, enter. Great, so this is where your applications, your desktop, libraries, all that is. We just made a new folder. That's all we did. We clicked new, made a new folder. MKDIR stands for make directory, make new folder, and we called it repo. So this is repo. So now we're going to change it into it. Hit CD space repo and hit enter. Now hit up on your arrow key twice. Yep. There we go. So now what's cool about the arrow key is you can like navigate your commands. So hit enter. These are the last two commands you entered 2 commands ago. So this says total 0. So there's nothing in here, which is perfect. So we're going to download the file from GitHub, and then we're going to move it here. So let's go back to your GitHub window. Yeah, close and minimize that. And then let's go to this one, and then let's go to, where did I go? Oh, can you change this branch to?
You have to go through your GitHub and then, you're right.
Go to Learning Paths. And then go to.
So you go to 0 Python.
0 Python
There you go,
for
yeah,
yes.
space,
And then click on Python
and then
Basics
you want
Breakout
to touch it
Session
to
Activity. That one, yep. Sorry, this is so unorganized.
So,
I need to
do
do
you
right
have
next
a
to
password?
click this download button here. This one. Yep.
Yeah.
Yeah. And then open up your Finder here.
I was thinking of.
And
Same.
then click
Yeah.
on.
Unless you got buttons up.
Right.
Go to your main area here. Click on applications, and then let's see if it'll let me hit the back arrow. Great. That just makes sense. Okay, we'll do the programmatic way.
Yep.
Open up the terminal again.
Yeah.
And type CP and hit space. Okay, now you're going to click that download and then drag it into here, and it'll just automatically put that link there. So if we go, yeah, there you are. You might have to put the 2 windows side by side. This window in the terminal, yeah. Oh my God, okay, we're good.
You got it.
So if you slide this window so it's like maybe covering half of your screen. There we are.
Yeah.
And then click the download button, and then a window should pop up. Just click it once. There we go. Then grab that. Then click here. Sorry for all the. There you go. All right, now hit enter. Oh wait, you might have to click on the window then hit enter. There you go. Now hit enter. Is it not like that? It said. Oh, hit up one more time and then put a period and then hit enter. Enter. There we go. Okay, so what this command does is it says copy. So it's making a copy, and then fun fact, your downloads are actually just files stored in somewhere on your computer. So it's going to users, your downloads file, and it's grabbing this book. By dragging it there, you told it like exactly where that was. And then the dot means just here. So it's saying copy from this location and then put it here. We could have also just drag that file into Finder, into this folder, but we didn't know how to get there from there. So, okay, so now type in, let's see if this will work, Jupyter, JUPYTER space notebook, and hit enter. And it should open up a browser. It might take a second. It's working. Since this thing is over here, but it hasn't returned back. And also, yes, you'll want to install command line developer tools. So that's just an Apple product, command line tools, and it allows you to like navigate with code. It should be in there. There it is. Okay, so now you can just click that. And it should be up and running for you. So you can hit, I never talked about Jupyter Notebooks. How you run a cell. You can hit Shift Enter. Have any of you worked in Jupyter Notebooks before?
We did once, but that was like last year.
Okay, let me
Yeah.
give the rundown of that. I realized I didn't talk about them at all. So at the top, here you've got your little, your bar where you can do like cell management and you can restart all your cells. One important thing to notice is in Jupyter, there's something called a kernel. So if you're running into issues, something's running forever, or you're getting an error and you want to wipe out all of your variables and like restart your connection to the Python interpreter, you can just do restart, or you can restart and clear output, and it'll clear all the outputs from your cells. So each of these cells can either be, so this is in Markdown. So if you double click in here, that's what this language is. And you can change that by hitting Escape M, and it makes it a Markdown cell. Or you can come up here and hit cell type. And look, it even tells you what the commands are. So when you're in Escape, when this is blue, you're basically in a different type of way of interacting with this. And these commands will work. So if I hit M, it makes it a Markdown cell. And if I hit Y, it makes it a code cell. When you hit, and then to run a cell, you would hit Shift Enter. And it runs that cell. So it executes the code that is contained in there. If there's output from that, it puts it out on the line right below it. So let's get to something useful here. So the cell Shift Enter, and it would rerun that. Now notice this says input 24 and this one says input 2. That's because one thing with notebooks is you can run these cells in any order. It doesn't have to be top to bottom, though most humans logically will organize their work that way, but theoretically you can run them in any order. That adds some complexities for deploying things to production, but that's notebooks. That makes it easier instead of having to fix one bug, rerun your entire Python program, then fix another bug, then rerun your entire Python program. You just run segments of code, so it's kind of the power here. If you want to add a cell, again, I'm going to give you all the keyboard shortcuts. You're going to hit Escape to get out. You hit A. A is going to add a cell above. Hit Escape to get out. B is going to add a cell below. If you want to delete a cell, you can hit the key D twice. So DD will delete a cell. DD will delete a cell. You can also just do all of those same operations up here. So run instead of Shift Enter. Stop to kill a cell. If a cell's taking forever, you can hit stop. Yeah, maybe I'll send a thing. I'll take a note. Maybe I'll send a thing on getting started with Jupyter Notebooks.
So now that I have the class one open, how do I get?
Yes. Let's go download that one. I think the one that you have open is these breakout activities. Let's get the intro to Python as well. Let's have that in a different, you know what, understand? Do you have Slack open? You do. I'm going to link that to Slack. Be faster. Make sure. Okay, let's see.
Mine says, deliver the phase and put one into a vertical window.
Introduction.
This is the second one.
Oh,
Name, print, that's why.
I did define it.
Yeah. What I was wondering.
Okay, if you click that link, that
My
just dropped in the Slack.
Unterminated stream. Like two. Because that's the, no second. Oh, you didn't.
And then click
Well, you don't, you have on
this
your.
download
You
button.
don't have another one. Oh, there it
I
is.
did.
But it's outside of.
Yeah, I haven't.
Perfect. And then
It's at. Oh.
I'm gonna help you with your Finder so we can make that easier. So let's go to Finder. We're gonna change the settings here.
Is it?
Then go to Finder, settings, is there a set, preferences?
Yeah.
Is it a sidebar?
Okay.
Click this one. Perfect. All right, now close that. All this did was make it so that I can see your home directory here. So click on this. Now you can see repo. So double click into repo
No,
here.
I cannot figure out.
Now we can just drag and drop that download right into there. So we'll just
Let's figure it out.
No. So try to figure it out.
I got the slashes. but I got
You
all
might
the
have to put them
lines.
like, yeah, side by side. Oh, there you go. Perfect. So now, if you go, what's really cool is if you go to your Jupyter that you already have open, if you click Jupyter now, up here in the right-hand corner, the left-hand corner, then you have both of them. So those are both in there. So now you can drag any files into that repo location, and they'll just pop up here in your, when you open up Jupyter Notebook.
And then just to open this up, do I just?
You just
like
click on it.
local host? Like let's say I close out a computer.
Oh, yeah, so to open it up again, you would just go to, on your terminal, you would go to repo, so you would navigate to repo, or just open up your terminal at your home directories. So, let's do it now, so just close all of this. Or at least these two, just close the Jupyter Notebook ones. Now let's open up your
It's
terminal,
a backslash and then a quote sign. You
and
have to
Well, let's say
use
if this is
a
yes, close that,
escape sequence,
terminate.
which is the
Let's
backslash
reopen
or
it.
whatever slash that is.
All right, so the first command you're going to want to do is
Backslash.
pwd. As soon as it loads, there we go, and then hit enter. And all this does is it tells you where you're at. So it says users, and then this is just your home location. This is what I added to your Finder, so you can see that now.
That
Now
and
go
then the
C
quote,
space,
and then
repo.
line, and then to add a quote, it's just the same.
and now you are into pwd again. Now, you'll see that you are now in your repo, now you put space dash L. LS just means list, and dash L means long, so list everything in my
What,
directory.
for like empty space?
Dash.
Or what?
I don't really space dash L.
It says it's a escape sequence. I don't,
LS.
so it'll, Python will remove the backslash and just put the quote.
So you say list everything in my directory. It says, yeah, I can see that you have 2 notebooks in here. So if you want to open that Jupyter Notebook again, you would write Jupyter Notebook, so Jupyter. That one was.
Oh, it's, your slash needs to go back, not
Oh.
forwards.
Do we have to remember all this?
That's a good question. I would tell you to remember, let's see, open terminal.
That should be before the.
And I guess what they stand for.
Oh, that's a good question. You would open your terminal and then
One quote.
you would, that would be your first step.
Okay, so print.
And then you would navigate to your file location where you want to run Jupyter Notebook.
Back.
And all that I mean by run Jupyter Notebook is it won't be able to see files before that location, it'll only be able to nest down.
Maybe once you
So
have single quotes.
you would want to put it after that. So
your screen.
for you, what that would look like on your computer, the way
Oh, sorry.
the
It's-
same
I
way
just
is people can set
lost
it up
it, right?
different ways.
But she's
But for
doing it
you,
because
you would
this
open the
breaks it to
terminal
this
and then
one.
you would put in.
Yeah, the
CD.
backslash
Breaks
ends
it
new
down
line.
instead of what
You know what,
I would
actually, I'm
do,
gonna
which I
do
like.
CD tilde
Yeah, that
first.
needs to be.
That is tilde.
No, wrong way.
That's
Get
this.
back.
Tilde is this key
No.
here.
Yeah.
So CD tilde, that'll take you to your home directory.
Front.
And then we
Did
would
we run
CD into repo. And then you would just put it into your.
The name print is not defined. So try changing.
I'm gonna put what these do
Yeah, I see.
in a different color. So you would want to go home,
I'll try running that.
and then you would want to change directory, which just means open that folder.
So maybe add a couple.
Maybe because it also.
And then you would want to run Jupyter Notebook.
Yeah. Run
Oh, and then
slash.
you have,
I've got 2 extra slashes
yeah.
around each,
And again, first you would open the terminal,
and then change your one.
and then 2 is all
To a
that.
backslash. Backslash. I cannot say.
I guess 3 is not Jupyter Notebook.
So leaning back, yeah. Try and run that now. Jeez.
Oh, but you have 2 on, 3 on Facebook?
Yeah.
We're trying to figure out how to
Yeah.
break the.
Let me check on our online friends here. All right, how are you guys doing online?
Good. You wanted us to start going through this questions or these things that you had, right?
Yes.
Okay, so I mean at this point I'm quite a few in.
Great.
Quick question for this B, for part B, store the phrase in part 1. Are you talking about the phrase from A?
Oh no, I added multiple things together here. Let me see. I gotta make sure that I didn't miss. You can probably tell by my numbering. Part B. Are you talking about advanced tool or?
Well, I'm talking about like store the phrase in part 1 into a variable, then use that variable
Oh.
to print.
I see what you're saying. No, I think I took out a piece. That's a good question. Store the phrase. I think I took something out in here. So no.
Okay. I can skip it if you just want me to move on to 2.
Just print anything 20 times.
Print anything 20 times.
Print
Okay.
everything 20 times.
Okay. That's a lot easier.
Yeah, I apologize for that. Thanks. Good call out. I did not, but I can.
There is
Yes.
a Google Doc
Perfect.
with everything on that you've been.
I'm just gonna do a screenshot of this attendance thing here.
Anything else? I was getting ready to take off.
I think I'm good.
You key to the door.
I'm gonna meet up with Charlie
Oh, that's what you
today.
are.
But
Oh, I got one.
I do have one. I slept there home today.
Oh, that's what it was. Okay. Yeah.
With my charger.
Okay. Perfect.
Great. Thanks, Nate.
Yeah.
All right. The screenshot function is not on here. Let's write these down. CD. We've got Brenda, Matt, Anna, Ted, James, Jody. Oh, there we go. Now I've got the screenshot thing. Mary. Did you say that you're not on StreamYard?
No.
What's your name again?
Missy.
Missy. Got it. I just want to make sure I got you.
Thank you.
Okay, I think I got everybody. We'll check our agenda here. Oh, hey, we're ahead. Why did I think we have like a whole nother hour, don't we?
Yep.
Yeah.
Oh, look at me. I was so worried we were starting late. I just flew through that. Okay, so take your time here, guys.
I'm not quite sure on the two flow control fix this code so it works in a more sensible way.
Yeah,
So we
let
just have
me-
to define yes.
Let me open this up so I can. That's assignment one. That's not right. Where am I here? Breakout session. Okay. So in this one,
Number two.
okay, sorry, what was your question?
I guess I don't understand what we're supposed to do.
All right, so this is more just trying to get familiar with debugging. So if we run this, do you have 8 legs? No, I don't have 8 legs. It gets a name yes is not defined. So if we go here to answer, we're trying to figure out why is it saying yes is not defined here at line 2.
Okay. Thank you.
Yep. So saying yes is not defined. I will come back to this. I'm going to eat a sandwich while we wait. We'll continue for another, you guys don't have to do all of these, but let's continue for another 5 minutes. And then we'll come back, and I'm just curious to hear the solutions that you guys found for some of these. When we do these in the future, we might break out into like individual groups. So we'll work with you guys online and see if we can somehow do breakout sessions. Okay, we are going to take a 10-minute break here. You guys can continue working if you want, or get up, go get a drink of water, use the restroom. When we come back, we'll go through these exercises, and then we will go over the assignment. And my goal with these exercises and assignments is to challenge you guys, I guess, to put some comfortable challenges though. So to stretch your skills, but hopefully not too far beyond that, especially given our time frame and kind of like tight nature of the class. But if that is the case, happy to adjust anything. So we'll get in there into the assignment. We'll see you guys back at, let's say, 8:25. Okay, I'm gonna mute and go off camera. I think I'm gonna move this over.
So my boss did his doctorate in statistics. I sent him the book that you said to get, and he's already purchased it.
Which one?
The Introduction to Statistical Learning with the Applications in Python.
You sent it to who?
My boss.
Oh, he's gonna like it.
Yeah, he's like,
You said his background is in statistics?
Yeah.
Yeah, he'll like it. It's very founded in statistics. The authors do a really great job, not just with the content that they put in there in terms of like its relevancy to the field, but also connecting it back to that. These are the statistics and like the foundational concepts of statistics that are underpinning this. Yeah, he'll like it.
I'm excited to read it.
It's a good book.
Go get a gas.
I haven't read the Python one yet. I need to read that one. It's been a
Okay.
while since I've reread it. But I'd say the first. Sometimes you get like a little bit to the end. It's a little less relevant, and they probably in support vector machines. They probably redone that, but definitely. Did I do that? I lost my mirror device here. Everything through section 8. Oh yeah, and then section, I maybe skip over support vector machines, but everything else.
Awesome. Cool, thank you for this.
Oh, I'm full of them.
I.
You guys will be tired of me by the end. I lost my TV monitor here. Let's try to reconnect. Oh yeah, no, go ahead. Thank you so much for that. I appreciate it. Why is this? Sorry for the hubbub on the virtual line here. I lost display here. Oh.
Not working?
Is there a remote by chance?
Right here.
Oh, good. I think I just need to hit later. There we are. Okay, here we go. All right, so let's come back, 825. What did you guys figure out for this first one? What were some troubles you ran into?
Yeah, that's hard.
So did you first try to maybe just copy all this and print, and did that work?
No. Well, my problem mainly was that I capitalized the free on print.
Oh, yeah, are you serious? Oh, yeah.
Those little typos will get us. On the phone, any solutions from your end?
Yeah, the three
And feel free to drop your solutions in this chat on Slack if you guys are comfortable. So it looks like the first thing we're running into is this quote here. So in Python, you can tell a string to start and you can tell a string to end. And here we're telling the string to start and then we're telling the string to end, but we actually want to print it, so that's causing a problem. Here, Matt shared his solution. Oh, there you go. So Matt stored his variable. Sorry, I will. If you guys look on Slack, you'll see it there. Matt stored something as a variable, and then he did string.format to actually print that variable out. Good solution there, Matt.
Thank you.
There's like many things in life, there's about 1 million different ways that you can solve this. I'll tell you a few things. In Python, there's something called an escape character. So you can see the highlighting difference. Jupyter Notebooks actually will highlight your syntax for you. You can see that that's actually becoming a string now. And we're having the same issue with this one. So we can actually, with triples. I'm going to put this all on one line. We're going to put this all on one line here, and then we're going to escape this character as well. So you can see now that's all a string. And then we're going to put this all on one line here, and we're going to try to run this. But, oh, you see that we only have 2 slashes here, because since the slash is an escape character, it's actually escaping its own slash, so this is kind of confusing. But if we add 2 more slashes there, that will enable us to actually get 1 slash out, which is a weird thing. But you'll see that this is all not on one line. This is all on one line, and the example has it on 3. So if we do something called a new line character in Python, you can do /n, and that'll actually put this on a new line. I accidentally put that before the space. We would probably not want a space at all.
Could you share the screen you're working on?
Oh, I'm so sorry. Absolutely. That's not helpful. There we are.
Thank you.
Yeah, thank you for letting me know. So here, what I was talking about is this /n. N means new line character. You'll see that in this print statement that's not actually printed out, but it actually adds a new line. So you can imagine we could probably add another new line character here, and boom, this would be on its own line as well. So that's a approach. Again, there's a lot of different ways that you guys can do this. I won't go through each of these because I just remembered that I did promise you guys to build a model every day. And so we are going to build a model, I promise. Anybody have a solution, but I'll ask you guys for your solutions, and then I'll share kind of the solution notebook at the end of class or tomorrow. Any solutions here for this one?
It's just to create that variable, just so whatever, and then that variable times 20.
Perfect. Can you drop that in the, if anybody's comfortable, drop that in the Slack channel maybe? Oh wait, that's right, you don't have access to the Slack channel, sorry. If you guys are comfortable, it'd be good just to share with everybody so other people can see what your solution might have been to this one. We'll do one more here. This control flow, what are the errors or issues that you guys found?
We quotes around the yes.
Quotes around the yes, let's do that. So right now, the yes not having quotes around it, it's interpreting that as a variable. So it thinks that that is something with a stored value inside of it, but we actually wanted it to be a string. What other issues did you guys notice?
Parentheses.
Parentheses? Where are the parentheses?
Outside of the quotation.
On the yes here?
Yes.
I think. Let's try that. Let's see what that does. Good question. So the parentheses typically indicate that we are trying to pass variables to a function. Do you have 8 legs? No. So what happened here is it asked for our input. This is how control flow works. This is what it's going to do. That input got stored into answer. Then we came to the second line and it said, if answer equals yes, we said no, and then it moved else, do you have 4 legs? So it moved this 4 legs, and I'm gonna say yes, and I think we're going to get an issue here. So it seems like it's working at first glance, but let's test the other alternative. You have 8 legs, yes, but then it says, oh, that actually does work.
Just the,
I think it's interpreting this. Yeah, go ahead.
Yeah, I was gonna say, so, shouldn't it be, equal yes for quad?
There you are. That is down here, right?
Yes.
Yep, you are a quad. So it had a do not equals instead of an equal equals. Yep, that was one of the other errors. It looks like that does work. I would maybe recommend just doing this without the parentheses. But it looks like, I think it's casting it as a tuple, and it's a tuple of 1. So I think that's why that's working.
I have one question.
Yeah.
So when you say in a sensible way, if you still put in, do you have 8 legs? Yes. You still get that you are a bicycle. How do you, because I don't think that's sensible if you have 2 answers right there. How would you put that you are a bicycle as like the last resort answer, I guess?
That's a great question. Any thoughts from you guys, first of all? All right. What I would maybe do is put in a function here called else. So in Python, if has friends. If has a couple functions called if, else, and I hope it's elif. Sometimes I get my programming languages mixed up. If. Okay, in some other languages, it's actually else if. So I was just double checking there. It is called elif. So in Python, you can use these conditions to do if answer equals yes, or if this is an apple, else if it's an orange, else if it's a pear. So you can tell it to do things in certain situations. So in this case, we can say if the answer is yes, else print you are a bicycle. Another way to do this would actually be if answer equals no, if we wanted to be really specific there. Let's see if that works. You have 8 legs, no. You have 4 legs, no. So apparently if you have 8 legs, you're not 4 legs, you're a bicycle. I guess that's not a very good example. I should probably rework this. Maybe I'd ask, do you have 2 legs? But hopefully that was the answer I was imagining in my head, but maybe it was a bit of a jump to get there, so I apologize. All right, feel free to share your answers to these in the Slack channel. I think a healthy Slack channel is a part of a good class. And then I will share the actual answers that I have to these as well in the Slack channel, probably tomorrow. I want to spend just a couple minutes on the assignment, which you guys will have a full week for. And then I want to talk about functions. So I'm trying to think of where to start here. I have this up. Maybe you guys can kind of see the whiteboard here. Sorry. So in modeling, we have, I'll take a picture of this afterwards, but some of this. Let's start to build a little bit of intuition for the space. And that statistics book is going to have all of these concepts in there. Again, free online. Also, you can probably look up YouTube videos. I'm sure somebody's made a YouTube video of it somewhere. I'll give you a couple of kind of words to explore here. Well, first of all, one question you guys might get is, what's the difference between like AI and machine learning and all that kind of stuff? This is my conception of it. Is AI is this giant umbrella. So we got this huge umbrella, and there's a lot of stuff in there. One part of that domain is something called machine learning. So this is what we're focusing on. I actually think there's another part of the domain called deep learning, which we'll touch on a little bit about neural nets at the end. And then as this kind of builds in technical competency, then or complexity, you get to AI. So they're just a little more sophisticated in their like computer science systems that support them. Okay, so now that that's clear as mud, let's talk about the domains of machine learning. So we're just going to focus on machine learning for this. I'll let AI stuff figure that out later. So in machine learning, there is a couple different domains. We have, I'm trying to think of how to organize this. Mostly we have two things. We have supervised learning and we have unsupervised learning. You guys have probably heard this before, but supervised just means that we know the answer. And this one means we don't know the answer. I'll give you examples. So if we want to predict the price of a house, we can look at all the prices of the houses in the history, and we can use that to learn what the price of a house that we don't know the price for might be, or what price it might sell for. So this just means that we have something here called labels. So in our training data, our historical data, what we're using to build our model has something called labels. This is also called a target variable. You might hear that. This is also called a outcome variable. It's got a lot of names. This is also just called Y. So when you look at mathematical formulas, or let's think of the most common model. We're getting to the model building part. You guys ready to build a model? Here we go. Y equals mx plus b. So if we think about, take you back to elementary school, middle school math, y equals mx plus b. Y, this is our outcome variable, our target variable, our label. It just means we know, we have labels of what we're trying to predict. I'm trying to think of another example. We're going to work with the iris data set. I'm going to ask you guys to read that in for your first assignment. It's got labels for different flowers. And so Y is the label of the flower. So it doesn't have to just be a number. It can be a categorical variable, but that's going to be the, we know what we're trying to predict. Okay, so now we have something else called unsupervised learning. And this means we don't have labels. So I have a bunch of customers. Can you group them together and tell me which customers are similar? So that's segmentation or clustering analysis. I can't really say that these customers are, this is what they are. They are high value customers or anything. I can't put a strong label to them, but I can tell you that they're similar to other customers that are near them. So when I was in my senior project, when I graduated from undergraduate, is I made a beer recommendation engine. So you tell me what beers you liked in the past, and I would recommend a new beer for you to try. At the time, it was really novel. I know there's a lot of apps that do that now. But basically, what I did is I implemented a clustering algorithm. So I did unsupervised learning. So I had all this data about beers. Maybe I had their how hoppy they were. Maybe I had their alcohol content. Maybe I had the color of the beer. And so if we think about those as kind of like on an XY plane, maybe I have color of beer. Maybe I have like hoppiness. I'm not really a beer aficionado, so I apologize for those of you who are. And then maybe we have like ABV. So how much alcohol is in this? Then I had all these, beers that had different attributes. Well, maybe some beers would be closer to each other in the attributes that they had than others. So I created these clusters. So it's unsupervised learning. I'm not really saying anything about them other than they're similar to their neighbors. But if you like a beer from this cluster, Maybe you'd like another beer from this cluster. So I'd recommend you another beer from the same cluster. So that's a very simple undergraduate recommendation engine. So that is unsupervised learning. So we have no labels, is what you'll see. So we're not trying to take all these and predict something from them. It's more about, tell me what's similar between these things, or group these things by similarity. Okay, so that's one way of slicing it. Next, we're going to get into another way. Okay, that's supervised and unsupervised at a 10,000 foot level. The other way of, I feel like I'm forgetting something. I don't think I am. Okay, the other way of slicing it is we have classification and regression problems. So we have classification. And we have regression problems. And these are all, let me think about this, make sure I'm not going to misspeak. I don't think so. These are all labeled problems. So these are all supervised. If we're saying it's classification or regression, we're saying it's a supervised thing. So in classification, we're trying to predict categories. And in regression, we're trying to predict what I'm going to call a scalar value. So this just means it's a number that can exist anywhere on a scale. So categories, this would be like apples, bananas, pears. And this would be, regression would be the price of a home, or the cost of gas, or classification would be, oh, this may be complicated. I was going to say a movie you might like. Those are, maybe that's too complicated. Probably a lot of things in that type of recommendation. So these are kind of the two domains. We're going to get back to this one a little later. This is going to have like decision trees and that type of stuff. We're going to start with regression first. So this is typically the place that most like machine learning courses start. And they actually start with this. So y equals mx plus b. So y, I'm just going to use the home price one because you guys ever use Zillow? So Zillow has has a machine learning model built into it. That is estimate, the Zillow estimate, that is it. So if we want to say we want to predict a Zestimate, y is going to be like our home price. And m is going to be, well, let's start with b. B is just going to be, given every other attribute is 0, what's our baseline? So B is kind of our baseline. In home prices, maybe different, not all problems like this is interpretable, what a baseline is, it doesn't always make sense. But in home prices, we might think of it as just the lot price. What if there's nothing, there's no house, there's no square footage, there's no bedrooms, there's none of these other things? Maybe we can interpret that as just the lot price. So M is going to be our slope that we're trying to predict. So, you know, B is over here, and then M is this slope. So how steep is it? What's that look like? So for a given variable. So when we talk about X, this is a given variable. Let's just pick one. Let's say that it's your square footage. So this would be M times your square footage plus some baseline. Maybe a lot with no house on it is worth $10,000 or something. Probably not in this economy, huh? So the way that these formulas actually work is your home price would be, M would have a value. So let's say every square foot, square foot is, what's reasonable there? $5? No, $10? I don't know, we're gonna make up a number. So we're gonna say 10 because it's easier to do. So every square foot, additional square foot in your house is worth $10. So this would be times the actual square feet of your house plus, let's say, $10,000 equals home price. So you can start to see how this is actually a model. So now when you give it X, when you give it, we have 2,000 square feet, then you have, oh yeah, that's not gonna work out very well, huh? 20,000 plus $10,000. This is going to be our home price of $30,000. Wouldn't that be great? Oh, great. It's probably a pretty bad model though, right? If you think about it. Time check here, 47. Okay, so all of this is to say, this is where we start. When you look at a lot of formulas for regression specifically, and maybe I'm getting ahead of myself because we will get there, but when you look at something called linear regression, a lot of times you'll see the formula kind of look like this. It'll say y hat instead of y is equal to beta. So you'll have this b with a long tail on it. It'll say beta 0 plus beta 1 x. And then maybe it'll have more terms. Maybe it'll say beta 2x, or maybe it'll just say 2n here. It can keep going. Sorry, this will probably say x sub 1. This might say x sub 2. So this looks kind of intimidating, but it's just y equals mx plus b. But what if we had more than one m? So we had the square footage for the house, but what if we wanted to add the number of bedrooms? What would that be? Is that M2? What if we wanted to add whether the basement was finished? Is that M3? So that's what this syntax represents. So when you see this in books or things, just know that, I'm just gonna write it out here. So we're gonna have y equals, let's say, square feet times x plus bedrooms times x, I'm going to put x1, x2, I'll explain why in a second, times bathrooms times x3, right? Let's just do that, plus our baseline. The reason we have x1, x2, x3, and what the heck is x? X is our data. So x is typically represented in this table format. Think of Excel, where we have rows and columns, right? And so we might have our y variable, we might have the home price historically, because that's what we're training on. So this might actually have rows here with home prices, and then we might have the square feet. Maybe this is 100, maybe this is 2,000, it's a really small house. And then maybe this is like a mansion at 5,000 square feet. And then, you got your number of bedrooms, maybe there's 1, 2, 3 bathrooms, etc., right? You guys get the idea. So you can have as many variables as you want. Well, this is x1, and this is x2, this is x3. So all it's saying is x at this column row, this specific, the first column, or x at the second column, or x at the third column, outside of our target variable here. And so that's that syntax. When you read machine learning stuff online, sometimes they might have like a big X and a little x, and that can get super confusing. I'll try to stay away from that and just know the X's are columns and rows. Sometimes the big X refers to like the data set as a whole. So if you say the big X of square feet, it means that entire slice of the data. And sometimes if you say little x, it just means for that row. So if I say little x here, maybe it's just meaning little x referring to $100. But so if we wanted to do that, maybe we might have different values associated with it. So what do we have here? We had 10 times x1 plus maybe every bedroom gets you another $20,000 or something. So 20,000 times x2 plus every bathroom $10,000 times x3 plus a baseline. So what did we say that was? $10,000. So you guys can start to see how we already added a bunch of variables. Now it's turning into like a complicated formula. So this is machine learning, this is linear regression, and this is what we're going to learn first, is how to build that formulas. How did we pick 10? How do we pick 20,000 or 10,000? How do we pick m? So when we think about m as the slope, how do we choose that value? That is gradient descent, and that is what we will learn next week. You guys don't have to worry about this too much. I'm giving you a precursor. Okay, so we got 8 minutes. We can make a model. We already made a model on the board. Let's make it in our homework assignment here. So in here, this is going to be your assignment. It has 3 parts. The first part, I'll come back to this. This is generating a known function. So I'm gonna have you create some fake data. I've already laid out the structure for 90% of this. You just have to, in this one line here, you're going to implement the build y equals mx plus b for a random variable, and then the rest will run. I'll actually give you guys the answer to this today. And then for the models for data, for this one, all you have to do is create these 2 models. So I want you to make m equals, and then put x plus 5. m2 equals 2x plus 1. And then try to run this, and it'll compare your 2 models here. And then, so those 2 points are just worth 15 points each. This is going to be kind of the bulk of the homework, which we'll talk about in next session, is pandas. So this is going to be EDA with pandas. This is all very open-ended here. You're going to import sklearn and pandas, and then read in the iris dataset, which is built into pandas. You won't have to like copy a CSV or anything. We'll go over this next time. And then try to answer some of these questions. What is the iris dataset? So look that up. What are we trying to predict? What type of machine learning problem is this? Is this a classification problem or a regression problem? And then just kind of explore the data. See if you can print the distribution for these different feature variables. Are there any missing data? Print the label, classes, counts, percentages for our target variables. Again, we'll go over pandas next time. If you find anything interesting, let us know. And then what are your thoughts on how you might measure the success of this problem? So again, very open-ended.
I'm sorry, when is this due?
Monday,
Okay.
a week.
Does
Does that work? Okay, no, not Wednesday. I will not do that to you guys. You'll definitely get the weekend.
have to do that, I would say.
No, all this Monday.
Monday.
Yeah, yep. Especially since for the second part, I don't think we'll cover pandas next time. All right, this is a lot, but what this is this is a function, which we'll talk about again next time. Any thoughts for how to build y equals mx plus b here? So what we're trying to do is, these are the different, 5 minutes, I got plenty of time. Okay, so what we're trying to do is we're trying to create some fake data. So as it says, create 1D data, one-dimensional data. And what this is a variable that we're passing into this function. We'll talk about scope next time, but basically you guys won't have to worry about this too much. We're going to stay with scripting mostly, but in this case, we want to create some artificial data. So what I want to do is I want to make a function that does 2x plus 1, because I want to train a model knowing that the function is 2x plus 1, and then I want to see how well the model does. So I want to compare different models, how they perform when I know what the function is. I know it's 2x plus 1 because I created the data to be that. So that's what this is going to do. So you have to write one line here of how might we make a function y equals mx plus b.
Does it look like print y equals mx plus b?
Yeah, we're just
I
gonna
would say this
do.
goes too easy.
We're gonna do y equals mx plus b. We won't print it because we want y to actually have the value. So we're gonna do y equals mx plus b. We're gonna hit enter and we're gonna hit, oh, sorry, you have to import numpy. Oh no, that's my mistake. I'll update this. You have to import numpy as np for this to work, and probably many other packages too. We may get another error here. mx. Oh, why did this not work? So it says mx is not defined when I tried to make y equals mx plus b.
M equals, you put 2.
M equals 2,
2.
Yep. And b equals 1,
Yeah.
but it says mx is not defined.
Do you have to like actually put the operators in there? So you put like parentheses.
Yes. Good job, guys. We got a time set. Oh, x is not defined because
Is it? It's a capital X.
capital X. Oh, that's my fault. Sorry. I forgot the import statements. Pi plot as PLT. I hope that's what it is. Nope, not plot, maybe. Hope that was what it was. I might have to go figure out what that. No, I thought it was pi plot. I have to go figure that out. I promise this runs. This is now the correct syntax. We can even show x comma y if we want to print that. Let me comment out plot because I made a mistake there. Here we go. So here's our x comma y. So we made when you input 0 for function 2x plus 1, you get 1. When you input 1, you get 3. When you input 2, you get 5. So there is our function. I did build in some random variance for this. So if you want to get more technical, you can add plus random variance. And then it's not exactly 2x plus 5. It's mostly 2x, or 2x plus 1. It's mostly 2x plus 1. But then it accounts for some natural variance. You're artificially introducing variance into your problem here. Okay, so this is the first answer to this one. All you have to do is y equals m times x plus b plus random variance. And you've got the first 15 points. So then here you just need to create your 2 models and then run this cell, and that will run. Okay, thank you guys.
Thank you.
We did well. We've got 5 seconds to spare. Thank you guys on the online here. Feel free to follow up in the Slack chat, and if there's any questions on this stuff, I expect there will be. Let me know, and we'll see you guys Wednesday.
Thank you.
Thank you.
Guys,
Thank you.
bye.